Hi everyone. I hope that you're all well and healthy and running. It's sad that we weren't able to go to any meets this year, but I was hoping we could at least use this time that we have to learn more about distance running and learn more about our sport in general. So to that end, I'm going to do a 3-week series on different aspects of distance running and training. And this first week, I'm going to be doing 3 videos. This is the first of those 3 videos. And the focus this week is on how to plan our training around energy system development. Next week, I'm going to talk about how we program our training for muscular and biological development. And the last week, I'm going to talk about how we can maintain good health while we're training. So when we run, our bodies are using energy from 2 main biological processes, at least for the distances we run in high school. These are the aerobic system and the anaerobic lactate system. So at the base of everything is ATP. If you remember from biology class, that's adenosine triphosphate. And ATP is what our cells use for energy. So at any given time, your cells have enough ATP for a 6 to 7 second burst of intense effort. And the difference between a person who can only goes 6 seconds and a person who can go 7 seconds, that's mostly biological and genetic. There's not much training that we can do to change that. Now we can change how far we get from point A to point B, how quickly we can get to point A to point B during that time period, but you can't train a 6-second person to do 7 seconds purely on cellular ATP. But ATP can be regenerated through 2 different energy systems, the aerobic system and the anaerobic system. And depending on how fast we're going, our energy needs at a given time determines which of those systems that we're using. Basically, the slower we go, the easier it is for our body to replace that ATP. So with the anaerobic system, we're not getting enough oxygen to efficiently replace our cellular ATP. What our body does then is produces ATP, but without oxygen. It's not efficient, and we waste about twice as much stored energy as we're able to use. So if you have potential energy for 6 molecules of ATP, you'll only be getting 2 when you're using the anaerobic system. And we are also producing waste products that make running very, very uncomfortable. If you've seen somebody lock up during a 400 or an 800, you know what it looks like. Hopefully you haven't experienced it for yourself, but it is quite painful. Also, when we're running at speeds fast enough to use the anaerobic system, we are running a far greater risk of injury to muscles or joints. In the anaerobic system, we are getting enough oxygen to actively replace our ATP without any waste. There is a limit, though, to this system, and it's based on how much sugar our body has in reserves, and this is stored within the liver. Most people will have about 90 minutes worth of sugar stored in their liver that they can use on any given day. Now, when it comes to racing, there are very few races that use just one system. The only race I can think of would be the 55-meter dash, and that's just running entirely off of cellular ATP. As soon as you move up to the 100-meter dash, you're using that cellular ATP plus anaerobic system. And when you go longer than 400, actually really longer than 200 meters, you have some aerobic system kicking in as well. In a 400-meter race, it's about a 30-70 split. 30% aerobic, 70% anaerobic. When you move up to the 800, it's 50-50. 1,600 meter race requires about 75% of your energy coming from the aerobic system and 25% coming from the anaerobic system. 3,200, it's about 85% aerobic, 15% anaerobic. And finally, a 5K is about 92% aerobic and only 8% anaerobic. So we can see that the longer the race, the more attention we need to place on our aerobic development. And in the very next video, I'm going to show you the different types of workouts and which ones affect the different systems. See you soon.